Hello, my name's Eric Wagner. I'm the business director for WebNMS. We're a division of Zoho. So WebNMS is think of it as a customizable framework designed to be extended for a particular domain. It could be mobile backhaul, carrier Ethernet, could be a oil rig monitoring. So we have a history of telecom experience. We've been doing this for about 15 years, and the applications that are being built in the telecom space are EMS or NMS type applications. And a few years ago, we were getting requests for monitoring smart meters, video equipment, cell towers, and they had the common need of a telecom EMS or NMS. And so we took our platform and started customizing it to handle this M2M space. So our business model is a platform. It's a framework that developers and architects will download. They will evaluate it. They'll take weeks or months to evaluate this platform. And then simply implement and rebrand it as their own. It's an OEM type of relationship. And part of the application is, because it's a platform, it has to be protocol agnostic. So we support SNMP, CLI, SOAP, REST, XML, southbound, and northbound. And this enables many different types of devices to be integrated. And the idea within WebNMS is, because it's highly customizable, you can do it right from the GUI. You can be a sysadmin to make modifications. You can change the platform behavior through XML configuration files, or you can program directly to a number of APIs. The platform is supported through multiple OSs. It runs on Windows, different flavors of Linux, Solaris. We have different databases that could be used, different like Oracle for high-end, Postgres for low, MySQL. So these decisions on the technology being used are driven by the technical requirements and some of the business requirements. So if you start looking at a carrier class type of management system, just to give you some perspective, these are multi-million-dollar systems, and they effectively run the telecom business. And the M2M applications are doing the same thing. So the platform is used by developers and architects. There's a SDK that's built off of Eclipse. There's plugins for Eclipse. We use database schema help with Hibernate. And the typical functional modules that you see in a management system are asset management, fault correlation, performance KPIs, device configuration, maps, topology, security, and so on. What's unique about us is we get into some very high-scale situations. We measure our system in terms of managed objects. This is an attribute to be managed, a environmental parameter, temperature or humidity. We get into millions of managed objects. So along the way, we do the gateways, RTUs. There's a number of different devices. We work directly with carriers, system integrators like Accenture, Aricent, IBM. And because of the platform, there's a number of ways to do integrations. So let me jump to the application. So this is a dashboard similar to what you've been seeing, but the idea here is it's widget driven. Each one of these can be moved and modified, and I can go in and add widgets. Say I want to see recent alarms, simply add them as I go. I can change the look and feel. I can drill down. I see that there's an emergency critical alert. It gives me a pictorial of what I'm looking at, what the recent alarms are, some of the environmentals, fuel levels, voltage, power meters, that sort of thing. We also get into Google Map integration. Every management system has a fault application, fault view. We have a number of events coming in. Again, these could be thousands per second, but if you correlate them, it gets down into tens per second. We also get into RTU configurations. So we start looking at the system settings, network interfaces, remote server settings, serial port settings, the I/O settings, alarm settings. And if an alarm comes in, I can set up certain actions. I can take if a door opens, make sure that the video camera prints out some images to show that. I can send a script or a diagnostic back to the device. I can start a device, restart a device. I can send an email alert, SMS. So there's a number of ways that you can customize the system. You start looking at performance monitoring. So if I'm just looking at, say, total fuel consumption, I want to look at the last 30 days, view the graph. And by the way, I should have told you, this is an example, a case study of a cell tower management. So cell towers, in this case, let me just jump ahead. So the use case of this cell tower management system is this was a infrastructure that was off the grid. There was no measurable data. Fuel theft was problematic. There were high periods of downtime. So how do you deal with that? So we implemented sensors looking at the fuel level, environmental data for temperature and humidity, information on batteries, lighting systems, energy meters, video cameras. So there's a whole system that you're looking at, and you want to be able to monitor and control. Getting closer to the and what's interesting for most people is what do these systems really cost? Now, if you look at the comparison of a IT management solution, an enterprise that has 500 devices, the cost for that type of application is sub $10,000. However, if you start getting into a carrier class type of infrastructure with high availability, someone mentioned 5 nines, that's the type of environment that we're in. We've worked with Motorola, who does the EVDO data for Verizon. Those type of management systems get into millions of dollars in terms of hardware, software, and services. For this particular cell tower management system, there's a couple thousand cell tower sites, and the actual requirements gathering and the authorization to do the project was probably twice the amount of time to actually implement the project. So the project called for 3 developers. These are Java developers, a project manager, a tester, documentation person. We implement a methodology called Agile Scrum, which is a iterative development process, lots of releases, getting feedback from the field. So the project duration was about 6 months. The software itself was $18,000. The deployment cost for a central management system was 10. The failover system was 5. And the professional services in all cost about $140,000. Then you add some of the commodity hardware to run it on and the RTU costs. So not all these solutions need to be very expensive, but there is a cost to it. So some of the metrics that we have gathered, the application is still considered early stage. There's a need for northbound integration with some of the OSS systems that is coming. Because of the open APIs that we use, that's easily done. What we've seen so far is uptime, which was measured, well, downtime could have happened in hours and days, or now system is down minutes at a time. Fuel theft is down 85%. They're constantly tweaking and learning about the system. This is data that they've never had before. So they're starting to automate the actions. They are setting up scripts to send diagnostics back to the device and gather more information so they can act upon it. There's weather, environmental data. They're tying into their fuel scheduling system. They're automating their maintenance routines. So these applications are still relatively new, but because it's new to them, it's still a learning process. Just to give you go back to the application, because this is a developer framework, there's a number of different capabilities to customize it. You have the device discovery, what to discover, a deep discovery, when to do a deep discovery. You can get into node configuration, how do you set up the alarms. There's trap parsers, filters, observers. So there's a number of these attributes that you can act upon and customize. Within the product, you have the capability to set up roles and views and groups. So you may want to give some users just read-only. Other people have read-write and have the capability to actually touch the device. There's capabilities within the product to manage and monitor WebNMS itself. So you start looking at the health and performance of the system. You have certain tools that go along with it, log files, audit files, who did what, when, and it acts as a troubleshooting tool. And let's get into, do a little more performance. Again, you can take a look at diesel generator hours used. And it effectively helps people make decisions about their system real time. As opposed to, I think there was the fruit application, they didn't have the data. They couldn't act upon it. Now the data is available to them. So we're getting into some other types of M2M applications. The traditional EMS, NMS is a great base. We've done that for 15 years. We have 25,000 deployments in the field. Customizing for different environments is relatively easy. We're starting to get into road infrastructure management, so they have signs on roads. Reliance is, in India is using us to deal with road management infrastructure. We get into some of the financial systems where they're doing ATM site management. Interesting one that has been working with recently is smart metering, power grid management. Again, this customer came to us about 3 years ago and said, this is what we want to do. We want to manage smart metering. And we go, well, yeah, we could do that. It's, what protocol do you use? You need fault, performance, configuration. It sounds just like an EMS, just sounds like an NMS. So again, just different applications, but the functional modules are the same. And just to end it, just to give you an idea of some of our customers, a lot of our system integrators are Accenture, IBM, Wipro, Tech Mahindra. A lot of the traditional telecom vendors Alcatel-Lucent, Genband, Broadsoft, service providers, Cox, Time Warner, AT&T. So they all need this common need for a management system to effectively run their business. Thank you.